This is example 32. So if we look at A first, we've got sine theta cos theta plus 2 sine theta equals 0. We've got to solve it in this interval from 0 up to 2 pi. And again, we know this is in radians because the angle is given in terms of pi. So that indicates that we're working in radians rather than working in degrees. So what we need to do first of all is we need to take this sine theta cos theta plus 2 sine theta. And if we factorise it, then we can take a sine theta outside of a bracket. And inside the bracket, we'd have cos theta plus 2, close the bracket, equals 0. So we've got two possibilities for this. We've got that either sine theta is equal to 0, or from the bracket, cos theta plus 2 equals 0, which means that cos theta would have to equal minus 2. So the first thing we know is that if we consider a graph of cos starts at 1 and actually goes down to minus 1 and never goes outside of those boundaries. So that's the cos in the range of 0 to 2 pi. So in other words, cos could never reach minus 2. So we can reject this one because cos theta can't equal minus 2. So we're only interested in this one, sine theta equals 0. So if we use our calculators, again set to radians mode, we'll get that theta's sine minus 1 of 0, and the calculator will give us 0 for that. And what we need to do is look at a sine graph. And so sine, if we label it in terms of radians, then we've got pi by 2, pi, and 3 pi by 2, and then 2 pi there. Okay. So the graph itself would look like this, going between plus and minus 1 as usual. So we can plot these points, makes it a bit easier to draw. And so what the calculator's given us is this value of the angle being 0, but we can see also we've got here and here in our range. So we've got sine theta, or theta rather, the angle is equal to 0, but also in our range we've got pi and 2 pi. If we now look at B, we've got an equation in terms of tan squared minus 2 tan theta equals 3, which we've got solving the range 0 to 2 pi. So this is really a quadratic if we think about it. So if we make it equal to 0, we've got tan squared theta minus 2 tan theta minus 3 equals 0. And you can, if you want, say let y equal tan theta. And so you can then get an equation in terms of y, and you'll see that that looks much more like a quadratic. So y squared minus 2y minus 3 equals 0. And if we try and solve that, what we'll end up with is that y is equal to 3. And also the other solution is y is equal to minus 1. So these are actually values of tan theta. So we've got solutions for tan theta, which are tan theta equals 3 and tan theta equals minus 1. And what we need to do is try and find the actual value of theta. So we're going to do tan minus 1 of theta of 3. So we're going to say theta is tan minus 1 of 3. And we'll put that in the calculator. We'll get 1.25 radians. So again, remembering that we've got to be in radians, okay, and also that's just going to be the closest value to 0 is what the calculator is going to give us. But there'll be other values, and if we do the same with this one, theta is going to be tan minus 1 of minus 1, and what the calculator will give us is that theta is equal to minus pi by 4. So to get all the values, the best way is to draw the graph again. So here we are. Putting on the asymptotes, which are at pi by 2, and also an asymptote at 3 pi by 2, and because we're interested in the range up to 2 pi. So if I draw the asymptotes in, I can now draw tan in that range. Tan would look like this, going through at pi, because that's the equivalent of 180 degrees if we think about the tan graph when it's measured in degrees, and then also that part of the tan graph. So this first one, 1.25, has actually given us the value which would give us 3. So that's 1.25 there. And because the tan graph repeats over pi radians, then if we add pi to that 1.25, and pi being 3.14, we'll get the next solution, which is there, which if we add pi to that, 3.14, then that's going to be 4.39. So the other solution from that one, in the range that we're interested in, is 4.39. And we can see that if we carried on, we'd be outside of this range, so we'd have gone beyond 2 pi. So those are the solutions given by tan theta equals 3. And then if we look at the other one now, the minus pi by 4 is actually the one that would be here when we go into the negative. So minus pi by 4. And that has given us minus 1. But that's not in the range that we want, because we want them in the range 0 to 2 pi. So what we need to do is just add pi to that to get the next solution. So if we add pi to minus pi by 4, we get 3 pi by 4. So that's the next solution along, 3 pi by 4. And then we can continue. So if we add again, so what we'll end up with, we're still in the range of 0 to 2 pi. So I'm adding a pi onto this value here to get me this value here. And so if I add pi onto 3 pi by 4, I actually get 7 pi by 4. And that's my other solution there, 7 pi by 4. And we can see that if we continued, we'd actually go outside of the required range. So we'd be beyond this 2 pi here, which is the upper value of our range. So we're not interested in going any further. Also, we must be very clear that we're rejecting this value because it's not in our range. So we reject that one. And the values that we're interested in that are solving this equation in our range 0 to 2 pi are 3 pi by 4 and 7 pi by 4, and also these two values here. The reason for doing some of them in decimals and some of them in terms of pi is if they are a nice easy fraction of pi, it's a lot nicer to write them like that, and also they're exact if we can write them in terms of pi. But because these aren't a nice fraction multiplying pi, then we would write them as a decimal. For this one, example 33, we've got sine theta equals cos theta, and again we've got to solve it in the interval 0 to 2 pi, and we know we're in radians because we're working in pi. So what we can do is we can use the identity that tan theta is equal to sine theta over cos theta. So this is a very useful identity and it should be becoming familiar now. So in that case, what we could do is we can divide both sides of this equation by cos theta, and if we do that, we get that sine theta over cos theta is equal to 1, and since sine over cos is equal to tan, we've actually got tan theta equals 1 is what it becomes, and that's the equation we then want to solve. So if we use the calculator, again being in radians mode, theta is tan minus 1 of 1, and what we'll get being in radians mode is pi by 4. But again, that's not the only solution in our range, so I try and just draw this graph quickly. We can see pi by 2, pi, 3 pi by 2, and 2 pi are important values in our graph because the asymptotes are there. So if we draw the graph of tan, it's going to look like this. And the value our calculator gave us was for tan theta is 1, and our calculator found us this value, pi by 4. And we can find all the subsequent values of tan theta by adding pi. So that will give us this value here, which is, if we add pi onto pi by 4, get 5 pi by 4. So there we go, that's our other solution, 5 pi by 4. And if we added another pi onto that, it would actually be outside of our range. So these are our two solutions in that range. And it's very important to learn the graphs, not only in degrees, but in radians as well, with that being your measure of angle. If we now look at B, what we've got is sine squared minus sine x cos x equals 0. So this one looks a little bit confusing to begin with. But what we're going to use is the same identity we've just used above. So this one, tan theta equals sine theta over cos theta. So if I was to divide both sides and every part of this by cos squared theta, what I'd actually get is cos squared underneath that fraction, and also cos squared underneath this one. And obviously 0 divided by cos squared x is going to be just still 0. So we know that since tan theta and theta can be interchanged with x, it's just another way of denoting the angle. Because tan theta is equal to sine theta over cos theta, this is actually tan squared theta, or tan squared x. So sine squared over cos squared will actually give us tan squared. And if we just expand the cos squared on the bottom here, just make it a little bit clearer what I'm actually doing, then since cos squared x is actually just cos x times cos x on the bottom of this one, then one of the cos x's can cancel with the cos x on the top, and so I'd be left with sine x over cos x, which again is just tan. So what I've got is tan squared x minus tan x equals 0. And so from that I can factorise it. I can take out a tan, because that's the common factor in that. So I can take a tan x to the front, and inside the bracket I'll get tan x minus 1 equals 0. So there's two solutions then from that. The first one being that tan x equals 0, and the second one from the bracket being that tan x must equal 1. And if we solve them, doing tan minus 1 of 0 from this one, the calculator will actually give us 0. And for this one, the calculator, tan minus 1 of minus 1 will give us pi by 4. So again, we need to draw the graph. I'm going to do it again because this time we've got a slightly different range. We're going between minus pi and plus pi. So our axes are going to look something like this. And we've got pi by 2, pi, minus pi by 2, and minus pi. And we've got the asymptotes again, this time at minus pi by 2 and also at plus pi by 2. So we can start to draw the tan graph. So it's going to go like that between the two asymptotes. And then on this side, it's going up to 0 at pi. And on this side, it starts at minus pi, goes up towards the asymptote. So that's the graph of tan in that range. If we had carried it on, it would have looked like this. So our calculators have given us, first of all, this value, 0, but we can see that we've got another solution at minus pi, and we have another solution at plus pi. So they're both in the range because it's equal to as well as less than, and seeing they're equal to. And for this one, the calculator has given us just one value. So this one, pi by 4, got 1. And going on the positive side, we don't have any more solutions until we get out of the range required. But if we go on the negative side and subtract pi to get the next negative solution, there we get pi by 4, take away pi, is minus 3 pi by 4, and that's our other solution. So these are our solutions in that range.